Okay, welcome to Hyperbolic Navigation by the one and only me. Okay, so what exactly is this? I've never heard of it before, so I doubt you guys have. So basically, it's a system which creates these hyperbolic lines by measuring the difference from two radio signals, the difference in distance between these radio signals from radio transmitters. So in math class, we learned and we know that these two points are foci, but in real life, they're these radio signal transmitters or dispatchers. And this a one main like station, which most commonly is like a boat is receiving these signals, but it's at a difference in time. So when you want to pinpoint that exact location, you use this navigation system to help determine that one location. So who actually uses this? In World War II, it was first used to help with bombs and missiles, and to help the navies like pinpoint where they were and navigate around the ocean. Now, the British Navy uses it, and the U.S. Navy, we have a system called LORAN, which they use this exact uses this exact system to help with bombs and missiles too, and with just to navigate around the ocean and to help them when traveling. And it's also seen in GPSs of different boats. Okay, so here is the math. Here we've got two signal dispatchers, D1 and D2, and they're both transmitting constant signals out. And we've got a boat here in the ocean that's receiving these signals. And we can find the hyperbola that this boat lies on, and we can then use that hyperbola to pinpoint this boat where it's located. So because these signals are transmitting at a constant rate, we can use this equation D equals R times T. The difference in the distance from D2 to this boat and D1 to the boat, the difference in these two distances equals the rate that they're being transmitted times the difference in the time that the boat is receiving them. So the rate that these signals are being dispatched is 0.186 miles per millisecond. And this boat is receiving these signals almost staggered because this D1 to the boat is clearly shorter than D2 to the boat. So this boat is receiving them 150 milliseconds apart. This comes out to be 27.9 miles. So this D2 to the boat minus D1 to the boat is 27.9. Now, if we draw this hyperbola, and we use this point right here, if we do D2, and we know that all of these points on this hyperbola, the difference from D2 to that point minus D1 to that point is always going to be 27.9, always. And so if we have D2 to this point minus this distance, that's 27.9. But we know that this distance, D1, this focus to this point, and D2, this focus to this point, we know these two distances are the same. So now we can subtract D2 to this point, we can subtract this main length from this one, and this will give us 27.9. This section right here is now 27.9. And now we also know that from the center here to this point, and the center here to this point, we know that these two distances are also the same. And we know that they are each half of 27.9, and they come out to be 13.95. And now, and these two dispatchers are both, they're 150 miles out from the center here. So we've got A is 13.95, and we've got C is 150. And now the equation for a hyperbola, we can put it over here to remind ourselves: x squared over a squared minus y squared over b squared equals 1. And so, b squared. And so we have a and c here, but we don't have b yet. And to find b, we can use c and a. So we can do c squared equals a squared plus b squared. And we know that c is 150, and we know a is 13.95. And so this now, b comes out to be 149.35. So now we've got our a and we've got our b, and now we can make our hyperbola equation. So we've got x over 13.95. We've got all that squared minus y over 13.95. I'm not sure if I said that. And then now we've got our y over our b, 149.35. All of that squared. This all equals to 1. This is now our equation that this hyperbola is, that this boat lies on. Okay. Oh, how do I get out of this? So here we've got two signal Okay, so I can get out of here. Uh-oh. One sec. Okay, sorry about the little interruption, but that was the math of how it is related into the real world and how you can actually use hyperbolic navigation, and it's not some silly little math problem that you're never going to use. And these are some different links that I use to help me understand this better. So thank you for watching. Hope you all enjoyed.